Let us continue foundation chemistry. Foundation chemistry, let us continue. In the last class we discussed about types of molecules. And the types of molecules, we'll take first one, monoatomic molecules. Monoatomic molecules. For monoatomic molecules, each molecule has an atom. That means one molecule will have one atom. So each molecule is having one atom. For this example for monoatomic molecules is noble gases. For this we can say again noble gases. Which are noble gases means one is helium. For helium symbol first two letters H. Now helium atom formula H. Helium molecule formula H. Then we can say neon. For neon first two letters is the symbol. For neon atom formula Ne. Neon molecule formula Ne. Next we will say argon. First two letters is the symbol Ar. Now argon atom formula Ar. Argon molecule formula Ar. Next we will say krypton. First two letters is the symbol for krypton. Now krypton atom formula Kr. Krypton molecule formula Kr. Next we will take xenon. Will take first two letters we will take Xe. Xenon atom formula Xe. Xenon molecule formula Xe. Next we can take radon. We can take radon formula Rn. Now we can say these are monoatomic molecules. Okay. Next we will go for atomicity. What is atomicity? Atomicity is called number of atoms per molecule. Number of atoms per molecule is called atomicity. That means one molecule is having how many atoms, that is called its atomicity. So one molecule per molecule means one molecule. One molecule is having how many atoms, that is called atomicity. So now for monoatomic molecules. Now we are taking monoatomic molecules. For monoatomic molecules, the atomicity is how much? For monoatomic molecules, what is the atomicity? So this molecule, monoatomic molecules means this molecule is having how many atoms? 1. Therefore, this molecule is having one atom. So its atomicity is shall we say it is 1? Yes. So for monoatomic molecules, atomicity is 1. That means each molecule is having one atom. Next we will take diatomic molecules. For this example we will see. First we will take hydrogen. For hydrogen symbol we will take. The first letter is the symbol of hydrogen, that we will write in capital letters. For hydrogen is the element. For this symbol of hydrogen, first letter is the symbol of hydrogen, that is capital H. Now we will take hydrogen atom. For hydrogen atom, symbol is capital H. Next we will take hydrogen molecule. For hydrogen molecule, formula is H2. Now see, hydrogen atom formula H, hydrogen molecule formula H2, because this molecule contains two atoms, two hydrogen atoms. Hydrogen molecule contains two hydrogen atoms. Hydrogen molecule contains two hydrogen atoms, we can say. Why? Because this molecule is coming under diatomic. Diatomic molecules means each molecule contain two atoms. Each molecule contain two atoms. That is called diatomic molecule. Sorry, for diatomic molecule, we have seen the example hydrogen molecule. Another example we will take for this. We will take nitrogen. We will take nitrogen. Nitrogen symbol first we will see. Symbol for nitrogen. What is the first letter of nitrogen? You see, capital N. So nitrogen symbol is capital N. Next we will take a nitrogen atom. We will take nitrogen atom. For nitrogen atom formula is N. Then we will take nitrogen molecule. We will take nitrogen molecule. We will take. For nitrogen molecule formula is N2. Nitrogen molecule formula is N2 because this molecule contains two nitrogen atoms. This molecule contains two nitrogen atoms. So nitrogen molecule contains two nitrogen atoms. Therefore, it is a diatomic molecule. In this way, oxygen molecule. In this way, oxygen molecule formula is first symbol we will write. For first letter is the symbol O. It is a diatomic molecule, so 2. Like this we are writing. Next, fluorine molecule. Next, we will take fluorine molecule. Symbol is first letter is the symbol that we will write in capital letter. This molecule is a diatomic molecule, so we will write 2 times. Next, we will take chlorine. Chlorine we will take its symbol. First letter is C, third letter is L. First letter we will write in capital, third letter we will write in small letter. Cl is the symbol for chlorine. It is a diatomic molecule, so we will write 2 here. Next we will take bromine. We will take. Next we are taking bromine. For this symbol, first 2 letters. First letter you write in capital, second letter you write in small letter. Sorry, bromine we have written. This bromine molecule is a diatomic, so we will write 2 here. Next molecule we will take iodine molecule. For this iodine molecule, first we will say the symbol. Symbol for iodine is first letter is a symbol. First letter is write as a symbol as capital. This iodine molecule comes under diatomic, therefore write 2 times. So these are the diatomic molecules. So diatomic molecules we have written. For diatomic molecules, what is the atomicity? What is the atomicity of diatomic molecules? So atomicity of diatomic molecules. Atomicity of diatomic molecules, how much that we will see. Now this molecule contains two atoms. This molecule contains two atoms. Therefore, atomicity is how much? 2. Like this you can say. These are diatomic molecules you can say. Next we will see triatomic molecules. Next we are seeing triatomic molecules. Triatomic molecules. For triatomic molecules, we will take the example. Example is ozone. Ozone formula is we will write the symbol of that oxygen symbol we will write and number of atoms we will write, that is 3. Therefore, ozone formula is oxygen 3 times. Oxygen 3 times you can say. So for triatomic molecules, what is as atomicity do you feel? Atomicity is 3 we can say. Next we will see tetraatomic molecules. Tetraatomic molecules. Tetraatomic molecules we will see. For this we will take an example. Example we will take as a white phosphorus. White phosphorus we are taking. Example for tetraatomic molecules. For phosphorus, symbol is first letter is P that we have written. Since atomicity is 4, so we are writing P4 is the formula of this molecule. So tetraatomic molecules. Tetraatomic molecules means that is white phosphorus P4. Tetraatomic molecules means white phosphorus P4 we can say. Next we will see octaatomic molecules. Octaatomic molecules. Next we are seeing octaatomic molecules. Octaatomic molecules example we can say rhombic sulfur. Rhombic sulfur we will take. Rhombic sulfur. For sulfur, First letter is S, that we will write. Since atomicity is 8, we are writing S8. S8. Therefore, rhombic sulfur formula is S8. It comes under octaatomic molecule. Its atomicity is how much? 8. So, we have seen regarding molecules. Then, in the molecules, we will see two types of molecules. One is called, two types of molecules we will see. One is coming under homoatomic molecules. Homoatomic molecules. Another one is coming under heteroatomic molecules. Heteroatomic molecules. Heteroatomic molecules. So, in the molecules, two types we are taking: homoatomic molecules and heteroatomic molecules. Homoatomic molecules. In this one, similar type of atoms will be there. Similar type of atoms. Similar type of atoms will be there. In this one, heteroatomic molecules means different types of atoms will be there. Different types of atoms will be there. Different types of atoms will be there. So homoatomic molecules means similar type of atoms. Heteroatomic molecules means different types of atoms. Different types of atoms we can say. Now we will take some formula. Now I will take a hydrogen molecule. Now I am taking hydrogen molecule. The hydrogen molecule formula is H2. This H2 means here H is containing 2 times, H plus H. So this hydrogen molecule formula is H2. This contains 2 hydrogen atoms. Therefore, in this one, shall we say similar type of atoms present? Yes. Therefore, it is coming under homoatomic molecule. Next example we will take water. For water, formula is H2O. This H2O means hydrogen 2 times present. H2 means hydrogen 2 times present, 1 and 1. Then what is present means here O, that is oxygen is present. So in this water, different types of atoms are there. One is hydrogen, another one is oxygen. Since different types of atoms present, it is coming under heteroatomic molecules. Heteroatomic molecules. Next we will take another example. We will take, that is sulphuric acid. We will take. We are taking a sulphuric acid. We will take. Sulphuric acid formula is H2SO4. Now we can say H2 means 2 hydrogens present. S means 1 time sulfur is present. O4 means oxygen present 4 times. Oxygen present 4 times. Now in this sulphuric acid, hydrogen is one type of atom. Sulfur is another type of atom. Oxygen is another type of atom. Therefore, in this sulphuric acid, different types of atoms present. Therefore, sulphuric acid comes under heteroatomic molecules. Okay. Next, we will see about atomic mass. Next, we will go for atomic mass. We are going for what in the sense? Atomic mass. What does atomic mass mean? In the word, what is there? See, here the word atomic contains atom. Then here mass is there. Therefore, what does atomic mass mean? Mass of an atom is called what? Atomic mass. Therefore, mass of an atom. Mass of an atom is called atomic mass. Okay, one atom. We are taking one atom. That atom mass is how much? That is called atomic mass. Now we will see the example for this one. Atomic mass of hydrogen will take. Atomic mass of hydrogen is how much means 1.008, and the unit is what means AMU. What is the meaning of AMU? What is the expression for AMU? AMU is called atomic mass unit. This is in another way it is given. In another way is 1.008 U. U is called what? U is called a unified scale. We can say. U is called unified scale. So atomic mass of hydrogen is 1.008 AMU, otherwise 1.008 U. Unit is this one. Now atomic mass is nothing but mass of an atom. Atomic mass is nothing but what? Mass of an atom. Therefore, what is the mass of a hydrogen atom? What is the mass of a hydrogen atom? Atomic mass is nothing but what? Mass of an atom. Atomic mass is nothing but mass of an atom. Now, atomic mass of hydrogen is how much? Atomic mass of hydrogen is 1.008 AMU. Therefore, what is the mass of hydrogen atom? What is the mass of hydrogen atom, do you feel? Shall we say mass of hydrogen atom is equal to atomic mass of hydrogen? Yes. So mass of hydrogen atom is 1.008 AMU. Mass of hydrogen atom is 1.008 AMU. Generally, mass will be expressed in grams, kilograms, milligrams like this. But here mass is given in AMU. So how to relate AMU and grams? How to relate AMU in terms of normal units, that is called grams. In order to relate, we will take a relation. 1 AMU is equal to how much means 1 by Avogadro number. 1 by Avogadro number, this many grams. So AMU and gram relation is so and so. AMU and gram relation is so and so. So we can say 1 AMU is equal to, this on simplification comes 1.67 into 10 to the power of minus 24 gram. This on simplification we are getting a 1.67 into 10 power minus 24, we will get it. So 1 AM is equal to so and so grams. 1 AM is equal to so and so grams, we can say. Now we will go for this mass of hydrogen atom. Now we will take mass of hydrogen atom. We will take mass of hydrogen atom. Mass of hydrogen atom is equal to how much means 1.008 AMU, that we will write into 1 AMU. This 1.008 AMU we can write it as 1.008 into 1 AMU we can write. Now let us convert this AMU into grams. To convert this AMU into grams, what we have to do? To convert this AMU into grams, what we have to do? What is the relation between AMU and grams? You see here, 1 AMU is equal to 1.67 into 10 to the power of minus 24 grams. Substitute this AMU relation into this place. So 1 AMU is equal to 1.67 into 10 to the power of minus 24 gram. This is a mass of hydrogen atom. So mass of hydrogen atom is equal to 1.008 into 1.67 into 10 to the power of minus 24 gram. It is a mass of hydrogen atom. Okay, so mass of hydrogen atom is equal to what we can say, 1.008 into 1.67 into 10 to the power of minus 24 gram is called a mass of hydrogen atom, we can say. Now we will take a mass of 2 hydrogen atoms. We will take mass of 2 hydrogen atoms. Mass of 2 hydrogen atoms means how much shall we say? Mass of 2 hydrogen atoms means, suppose here we are taking how much, in the sense 2 we are taking. Here we are taking 2. Mass of 2 hydrogen atoms. Mass of 2 hydrogen atoms means how much shall we say? Shall we multiply this by 2? Shall we multiply this by 2? Okay. So mass of 2 hydrogen atoms means above term we have to multiply by 2. Sir. Now we will take a mass of Avogadro number. Mass of Avogadro number. This number is called Avogadro. This number is called what means? Avogadro. This number is called Avogadro. So mass of Avogadro number of hydrogen atoms is equal to how much shall we say? Mass of Avogadro number of hydrogen atoms is equal to how much shall we say? Equal to this one. We have to multiply this with Avogadro number. So we will write 1.008. This 1.67 into 10 to the power of minus 24 into Avogadro number we will write. Avogadro number we are writing. Unit we will write gram. Unit we have written, gram we have written. Then we will see, now we see this 1.67 into 10 to the power of minus 24 is a reciprocal of this Avogadro number, isn't it? This 1.67 into 10 power minus 24 is a reciprocal of Avogadro number. Therefore, this and this cancels. So, on cancelling those two, what is the result? What is the result? 1.008 unit is gram. So, mass of Avogadro number of hydrogen atoms. See that mass of Avogadro number of hydrogen atoms is how much? 1.008 grams. Now we will see mass of hydrogen atom. See, mass of hydrogen atom is how much? 1.008 AMU. So 1.008 AMU means one hydrogen atom. Okay, 1.008 AMU contains how many hydrogen atoms? One hydrogen atom. 1.008 AMU contains one hydrogen atom, we can say. But 1.008 gram, this 1.008 gram contains Avogadro number of hydrogen atoms. Okay, 1.008 grams contains Avogadro number of hydrogen atoms. Therefore, now see the difference. 1.008 AMU of hydrogen, 1.008 AMU of hydrogen, then 1.008 grams of hydrogen, 1.008 grams of hydrogen. What is the difference? 1.008 AMU of hydrogen, then 1.008 grams of hydrogen. What is the difference between them? 1.008 AMU of hydrogen means it is called mass of an hydrogen atom. Mass of hydrogen atom. Okay, so 1.008 is called 1.008 of hydrogen is called mass of hydrogen atom. Mass of hydrogen atom. Okay, mass of hydrogen atom. 1.008 gram of hydrogen means this is called mass of Avogadro number of hydrogen atoms. Mass of Avogadro number of hydrogen atoms. Mass of Avogadro number of hydrogen atoms. Okay, so 1.008 gram of hydrogen means mass of Avogadro number of hydrogen atoms, we can say. Then this mass of Avogadro number, this Avogadro number we can say in another word. What is another word in the place of Avogadro number is 1 mole. 1 mole we can say. So mass of 1 mole of hydrogen atoms. In this way also we can say. In the place of Avogadro number we can say 1 mole. In the place of Avogadro number we can say 1 mole. Therefore, this 1.008 gram is also called a mass of 1 mole of hydrogen atoms. Mass of 1 mole of hydrogen atoms we can say. This 1.008 gram of hydrogen we can say in another manner. What is that means? That is called gram atom of hydrogen. Gram atom of hydrogen. Like this we can say. Gram atom of hydrogen. 1.008 gram of hydrogen. 1.008 gram of hydrogen we can call it as a gram atom of hydrogen we can call. Then 1.008 gram of hydrogen we can say in another manner, that is 1 gram atom of hydrogen. We can say 1 gram atom of hydrogen. Like this also we can say 1 gram atom of hydrogen. 1.008 gram of hydrogen we can call it as 1 gram atom of hydrogen. Like this we can say. Another name for 1.008 gram of hydrogen is what means gram atomic mass. What is that means? Gram atomic mass of hydrogen. We can call this as a gram atomic mass of hydrogen. We can say this as gram atomic mass of hydrogen. 1.008 gram of hydrogen we can call it as a gram atomic mass of hydrogen we can call. So 1.008 gram of hydrogen we can say as 1 gram atom of hydrogen we can say. 1.008 gram of hydrogen we can call it as a gram atom of hydrogen. Then 1.008 gram of hydrogen we can say as a mass of 1 mole of hydrogen atoms. 1.008 gram of hydrogen we can also call it as mass of Avogadro number of hydrogen atoms. So 1.008 gram of hydrogen can be said in these terms. 1.008 gram of hydrogen can be said in these terms. These are the terms we can use for 1.008 gram of hydrogen. Sir, next we will see next element we will take next element atomic mass of helium. Atomic mass of helium is 4 AMU. Atomic mass of helium is 4 AMU. Now, regarding this, some points we will see. Atomic mass of helium is 4 AMU. Now we will see what is the mass of helium atom. what is the mass of helium atom? We'll see. Mass of helium atom is nothing but atomic mass. So mass of helium atom is 4 AMU, we can say. Otherwise 4U we can say. Mass of helium atom is 4 AMU or 4U, like this we can say. Then how to say mass of helium atom? How to say mass of helium atom in grams? So mass of helium atom in grams, that we will see. So this 4 we will write. This AMU we will convert into grams. To convert AMU into grams, we will multiply this 4 by this number. Okay, this 4 by this number. So 4 into 1.67 into 10 power minus 24 gram is called mass of helium atom. So mass of helium atom is equal to 4 into 1.67 into 10 to the power of minus 24 gram. Next we will say mass of Avogadro number of helium atoms. Mass of Avogadro number of helium atoms, we will say mass of Avogadro number of helium atoms. So what you have to do means atomic mass, you see atomic mass is 4 AMU. So mass of one helium atom is 4 AMU. In the place of AMU, if you write gram, then it will become a mass of Avogadro number of helium atoms. So mass of Avogadro number of helium atoms, we can say it as 4 gram, we can say. Next, in the place of Avogadro number, what we can say means 1 mole. So if you say mass of 1 mole of helium atoms, how much value we can say? Same 4 gram we can say. Then we will say gram atom of helium. Then we will say gram atom of helium. Gram atom of helium is how much means? Same this 4 gram. Gram atom of helium is gram atom of helium is 4 gram, we can say. Gram atom of helium we can say as 4 gram. Then we will say what is the 1 gram atom of helium? What is 1 gram atom of helium? 1 gram atom of helium is how much means 4 gram. Next we will ask, next question is what is the gram atomic mass of helium? What is the gram atomic mass of helium? That is how much means 4 gram. Gram atomic mass of helium is how much? 4 gram, we can say. So this this atomic mass term we can use like this. This atomic mass term indicates in these ways. Atomic mass term indicates like this. So now we will take some questions regarding this concept. We will take some questions regarding this concept. Now, what is the mass of 10 atoms of chlorine? 10 atoms of chlorine. 10 atoms of chlorine in grams. 10 atoms of chlorine in grams. Okay. What is given data? Given data is atomic mass of chlorine. Atomic mass of chlorine is given 35.5 AMU. Atomic mass of chlorine is given 35.5 AMU. Now the question is what is the mass of 10 atoms of chlorine? 10 atoms of chlorine. So 10 chlorine atoms we are take, that mass we have to find it. 10 chlorine atoms we are taking, that mass we are finding. So how to find that we will see. First we will take the given data. We will take given data is what? Atomic mass. So given data is atomic mass of chlorine. So atomic mass of chlorine is how much means 35.5 AMU. Therefore from this we can say mass of chlorine atom. So mass of chlorine atom is how much means 35.5 AMU. How to convert this into grams? So 35.5 we will write AMU in terms of grams, for which we will write so and so. We will write AMU in terms of grams. So mass of one chlorine atom is this much. Mass of one chlorine atom is this many grams. Now we will see mass of 10 chlorine atoms. So mass of 10 chlorine atoms. Mass of 10 chlorine atoms we want. So multiply this by 10, we will get a mass of 10 chlorine atoms. So this 35.5 into 1.67 into 10 to the power of minus 24, multiply with 10, we will get a mass of 10 chlorine atoms. So you got a mass of 10 chlorine atoms, you got it. Okay. We will see next question, we will see. What is the what is the mass of 1 by 4 moles of 1 by 4 moles of sodium atoms. 1 by 4 moles of sodium atoms. Sodium atoms in grams. In grams, given data is atomic mass. Atomic mass of sodium is given. Atomic mass of sodium is given, that is 23. Atomic mass of sodium is given, that is 23. Here unit is not mentioned. Unit is not mentioned means that meaning is AMU, atomic mass unit. Unit is AMU. Okay. So how to find this? How to find this we will see. First we will take atomic mass of sodium. We will take atomic mass of sodium. Atomic mass of sodium is how much means 23 AMU is given. Next we will take gram atomic mass of sodium. Next we will take gram atomic mass of sodium. We will take gram atomic mass of sodium is 23 grams. Now see the difference. Atomic mass of sodium is 23 AMU. Gram atomic mass of sodium is 23 grams. Here unit is AMU, whereas here unit is gram. So gram atomic mass of sodium is 23 gram. Gram atomic mass is nothing but mass of 1 mole of atoms. Mass of 1 mole of sodium atoms. So mass of 1 mole of sodium atoms is equal to how much means 23 gram. Mass of 1 mole of sodium atoms is equal to how much means 23 grams. Now what is the question? Mass of 1 by 4 moles of sodium atoms. So we have to find mass of 1 by 4 moles of sodium atoms. Mass of 1 by 4 moles of sodium atoms we have to find it. That is equal to 23 by 4 grams. Mass of 1 by 4 moles of sodium atoms is this much. Next question we will see. We will go for next question. What is the mass of magnesium? What is the mass of magnesium required? What is the mass of magnesium required to have 3.015 into 10 to the power of 23 electrons. Given additional data is atomic mass of magnesium. Atomic mass of magnesium is given, that is equal to 24. Atomic mass of magnesium is given. Set. How to find this? That we will see. Now we will take element is magnesium. We will take magnesium. For magnesium, regarding electrons they are saying, for magnesium atomic number we will take. The atomic number of magnesium is how much means 12. Therefore, magnesium atom contains protons. So number of protons per magnesium atom will take. Number of protons per magnesium atom how much means, that is its atomic number. Atomic number is nothing but number of protons. Atomic number of magnesium is 12. Therefore, number of protons per magnesium atom is 12. Then number of electrons will see. Number of electrons per magnesium atom is equal to number of protons. Therefore, it is equal to 12. Therefore, magnesium atom is having how many electrons means 12 electrons is there. One magnesium atom is having 12 electrons. One magnesium atom is having how much means 12 electrons. Set. So we can say that 12 electrons present in one magnesium atom. 12 electrons present in one magnesium atom we can say. Now in the question, how many electrons given? You see, number of electrons given is 3.015 into 10 to the power of 23 electrons given. So these many electrons present in how many magnesium atoms? So that is equal to 3.015 into 10 to the power of 23 by 12. By 12 we can say. So these many magnesium atoms we can say. So now we got a number of magnesium atoms we got number of magnesium atoms. So number of magnesium atoms required is number of magnesium atoms required is equal to how much means 3.015 into 10 to the power of 23 10 to the power of 23 by 12. It is number of magnesium atoms. Now they are asking a mass of magnesium for which what is given? Atomic mass is given. So now we will take atomic mass of magnesium. Atomic mass of magnesium is how much means 24 AMU. Therefore, mass of magnesium atom is how much? Mass of magnesium atom is equal to, we can say 24 AMU. We can say, we will write AMU in terms of grams. We will write, so 24 into AMU will convert into grams. So 24 into 1.67 into 10 to the power of minus 24 gram. So mass of magnesium atom, we said mass of one magnesium atom. Here how many magnesium atoms are there? These many magnesium atoms are there. So for one magnesium atom mass is this much. For these many magnesium atoms, what is the mass? That we have to see. For those many magnesium atoms, those many means 3.015 into 10 to the power of 23 by 12. For these many magnesium atoms, what is the mass? Okay, it is the mass of one magnesium atom. So for these many magnesium atoms, what is the mass? That is equal to this 24 into 1.67 into 10 to the power of minus 24 into 3.015 into 10 to the power of 23 by 12. Now we will simplify this one. Will simplify this 24 and 12 we are cancelling, so we are getting like this. Then next step we will see. This 2 we will write 1.67 into 10 power minus 24 we can write as a reciprocal of Avogadro number. So 6.023 into 10 to the power of 23 into this number 3.015 into 10 power 23 will write. Will cancel all. So what we are getting means 1. So mass of magnesium required is how much? 1 gram is required. Mass of magnesium required is 1 gram. We can say mass of magnesium required is 1 gram. We can say. Sir, this is about regarding this atomic mass. Next we will see about molecular mass. Now what is meant by molecular mass? So molecular mass means you see that it is mass of what? It is a mass of what means mass of a molecule. Therefore, what is the meaning of molecular mass? It is called mass of a molecule. We can say it is called mass of a molecule. So molecular mass, what is meant by molecular mass? It is called mass of a molecule. Molecular mass means we can say it is as a mass of a molecule. We can say. Sir, now we will see molecular mass of element. We will see. So molecular mass of hydrogen will take. Molecular mass of hydrogen is equal to what we have tried means number of atoms per hydrogen molecule. Number of atoms per hydrogen molecule into atomic mass of hydrogen. Like this we have take atomic mass of hydrogen we have take. Number of atoms per hydrogen molecule is 2. Atomic mass of hydrogen is 1.008 AMU. Because one hydrogen atom means 1.008 AMU. Molecule contains 2 atoms. Therefore, what is its mass? 2 into 1.008. Okay. So, one hydrogen atom means 1.008 AMU. Molecule means what? Molecule means how many atoms are there? Hydrogen, 2 atoms are there. Therefore, we are multiplying this 1.008 by 2. So, molecular mass of hydrogen is how much means 2 into 1.008 AMU. Like this we can say 2 into 1.008 AMU. It is a molecular mass of hydrogen. Set. So, now we got a point. Molecular mass of hydrogen we got. Molecular mass of hydrogen is how much means? 2 into 1.008 AMU. 2 into 1.008 AMU. Like this, how to find the molecular mass of other substances? Now we will take example is atomic mass of nitrogen will take. Now we will take atomic mass of nitrogen. Atomic mass of nitrogen is equal to how much means 14 AMU. So what is the molecular mass of nitrogen? That we will see. Molecular mass of nitrogen. Molecular mass of nitrogen will see. Nitrogen molecule formula is what? N2. Nitrogen molecule formula is N2. So write this 2 and multiply this 2 with its atomic mass. Atomic mass is 14. Therefore, molecular mass of nitrogen is how much means 2 into 14 AMU. 2 into 14 AMU we can say. It is the molecular mass of nitrogen we can say. In this way, we will calculate molecular mass of other substances. For example, we will take white phosphorus, that is P4. For this molecular mass means write this atomicity 4 and multiply this 4 with its atomic mass. Atomic mass of phosphorus is 31. So molecular mass is 4 into 31. We will take another example. Octaatomic molecule S8 will take. For this molecular mass we have to find. First take its atomicity. Multiply its atomicity with its atomic mass. Atomic mass of sulfur is how much? 32 AMU. So 8 into 32 AMU is called molecular mass of this sulfur. Molecular mass of sulfur. Next we will take heteroatomic molecules. Water will take. Its molecular mass we want. So first you take hydrogen. Hydrogen how many times present? 2 times. Multiply this with hydrogen atomic mass, then write plus. Then take oxygen. Oxygen how many times? 1 time. Multiply this 1 with oxygen atomic mass. Now we will write this 2 will write. This hydrogen atomic mass will write 1.008. Then plus this 1 we will write. This oxygen atomic mass will write 16. This is equal to roughly 18 AMU. So what is the molecular mass of water? Molecular mass of water we can say 18 AMU we can say. Likewise, we will take some other element. For example, K2Cr2O7. This is a compound. This compound name is potassium dichromate. The compound name is called potassium dichromate. How to see molecular mass? So to see molecular mass, first you take first element potassium, that is present 2 times K. Then next element is chromium, that is present 2 times, that we will write. Next element is oxygen, that is present 7 times. So oxygen present 7 times we have written. So this 2 we will take. Then atomic mass of potassium we will take, that is 39. Then this 2 we will take. Atomic mass of chromium we will take, that is 52. Then plus this 7 we will take. Then oxygen atomic mass will substitute, that is 16. So this gives a molecular mass of potassium dichromate in AMU. So molecular mass, how to find? How to find a molecular mass, that we got an idea. One more example we will take. We will take the compound is H2S2O7 called oleum. How to find its molecular mass, that we will see. Now first element is hydrogen, that is given 2 times. So 2 into 2 times hydrogen. Then sulfur is given, that we will take 2 times sulfur. Then oxygen is given 7 times oxygen, that we will write. Next we will substitute atomic masses. Hydrogen atomic mass is 1.008 mu. Sulfur atomic mass is 32. Then 7 into oxygen atomic mass 16. This on simplification gives oleum molecular mass. Oleum molecular mass we can get it. So we can calculate molecular mass in this way. Suppose we are taking sulphuric acid. Sulphuric acid we are taking. This H2SO4 is called what means sulphuric acid. For this sulphuric acid, how to find molecular mass, that we will see. Hydrogen is present 2 times. Hydrogen is present 2 times. Sulfur is present 1 time. Sulfur is present 1 time. Oxygen is present 4 times. Oxygen is present 4 times. Now we will substitute respective atomic masses. Hydrogen atomic mass is how much? 1.008 AMU. This 1 into sulfur atomic mass will substitute 32 AMU. This 4 into oxygen atomic mass will substitute, that is 16 AMU. Now this on simplification we are getting roughly 98 AMU. So this is called a molecular mass of sulphuric acid. So in this way we can find a molecular mass. Now we got molecular mass, we got it. Well, molecular mass we got it. That means molecular mass we got it means we know mass of molecule. Now we'll see regarding this. We'll take now one sulfuric acid molecule. One sulfuric acid molecule. One sulfuric acid molecule contain how many oxygen atoms? How many oxygen atoms? What can we say? How many oxygen atoms? One sulfuric acid molecule contains how many oxygen atoms? For which you see the formula. Formula is there H2SO4. How to read this formula? This formula we can read as one sulfuric acid molecule contains two hydrogen atoms, one sulfur atom, four oxygen atoms. Like this we can read. Okay, now see, one sulfuric acid molecule contains two hydrogen atoms. We can say, comma, one sulfur atom and four oxygen atoms we can say. Okay, now the question is what? One sulfuric acid molecule contains how many oxygen atoms? How to respond it? How to respond? One sulfuric acid molecule contains how many oxygen atoms? What answer shall we say? One sulfuric acid molecule contains how many oxygen atoms? Four oxygen atoms. One sulfuric acid contains four oxygen atoms we can say. Next, one potassium dichromate molecule. One potassium dichromate molecule contain one potassium dichromate molecule contain dash number of dash number of dash number of chromium atoms. Dash number of chromium atoms. Dash number of chromium atoms. What shall we say? One potassium dichromate molecule contains how many chromium atoms? One potassium dichromate molecule contains two potassium atoms, two chromium atoms, seven oxygen atoms. So what is the answer? We can say 2. That means how many number of chromium atoms? 2 number of chromium atoms we can say. So one potassium dichromate molecule contains 2 chromium atoms. So next we will see. Now, three atoms of hydrogen on combination with required number of oxygen atoms to give dash number of water molecules. Dash number of water molecules. Dash number of water molecules. How many water molecules will you say? 3 atoms of hydrogen on combination with the required number of oxygen atoms to give dash number of water molecules. Dash number of water molecules. So, for this, how to solve this? That we will see. Now, if we take one water molecule, this contains two hydrogen atoms. Okay, so two hydrogen atoms present in one water molecule. Here in the question, what is given in the question? 3 hydrogen atoms. So 3 hydrogen atoms present in how many water molecules? Okay, so one water molecule contains 2 hydrogen atoms. So 3 hydrogen atoms present in how many water molecules? 3/2 water molecules. 3/2 water molecules we can say. 3/2 water molecules we can say. Okay, next we will see. Now 1.5 moles of chromic acid. 1.5 moles of chromic acid formula H2CrO4. Chromic acid formula H2CrO4. Okay, 1.5 moles of chromic acid contains how many moles of oxygen atoms? How many moles of oxygen atoms? Okay, 1.5 moles of chromic acid contains how many moles of oxygen atoms? How to respond for this question? How to respond for this question, that we'll see. Here, what is the question? 1.5 moles of chromic acid contains how many moles of oxygen atoms? Set. Now I will take chromic acid. Chromic acid formula is H2CrO4. This I am considering this as 1 mole. Now see, 1 mole of chromic acid. 1 mole of chromic acid contains 2 moles of hydrogen atoms. 2 moles of hydrogen atoms, comma 1 mole of chromium atoms. 1 mole of chromium atoms and 4 moles of oxygen atoms. Like this you can say. Now see, 1 mole of chromic acid contains 2 moles of hydrogen atoms, 1 mole of chromium atoms and 4 moles of oxygen atoms. Okay, if you say, suppose if you say one molecule, if you say 1 molecule of chromic acid, if you consider like this, 1 molecule of chromic acid contains 2 hydrogen atoms, 1 chromium atom, and 4 oxygen atoms. 4 oxygen atoms we can say. Okay, so 1 molecule of chromic acid contains 2 hydrogen atoms, 1 chromium atom and 4 oxygen atoms. Like this you can say. Okay, have we got the difference between these two? If you take 1 molecule, we have to talk in terms of number of atoms. If we take 1 mole, then we have to talk in terms of moles of atoms we have to talk. Okay, so 1 mole of chromic acid contains 4 moles of oxygen atoms. Now here given the question is 1.5 moles of chromic acid contains how many moles of oxygen atoms? It is a question. Okay, you see that 1.5 moles of chromic acid contains how many moles of oxygen atoms is a question. What is the given data we know? 1 mole of chromic acid contains 4 moles of oxygen atoms, that we know. Okay, so we know that 1 mole of chromic acid, 1 mole of chromic acid contains 4 moles of oxygen atoms. We know 4 moles of oxygen atoms. 1 mole of chromic acid contains 4 moles of oxygen atoms. Therefore 1.5 moles of chromic acid contains how many moles of oxygen atoms? That we have to see. So multiply 4 and 1.5, you will get 6 moles of oxygen atoms. 6 moles of oxygen atoms you are getting. Therefore 1.5 moles of chromic acid contains how many moles of oxygen atoms? Means 6 moles of oxygen atoms. 6 moles of oxygen atoms. Okay, in terms of moles we discussed this question in terms of moles. Now next question, you see that next question is 2 moles of water molecules. 2 moles of water molecules contains how many moles of oxygen molecules? How many moles of oxygen molecules? That is a question. Here how to respond this, that we will see. Now we will take water. Water formula is this. Now 1 mole of water contains 1 mole of water contains how many hydrogen atoms? 2 hydrogen atoms. 1 mole of water contains 2 hydrogen atoms. 2 hydrogen atoms means what? 1 molecule. 2 hydrogen atoms means 1 molecule. Okay, and how many oxygen atoms? 1 oxygen atom. 1 oxygen atom. 1 oxygen atom means how many molecule? Half molecule. Half oxygen molecule. because oxygen is diatomic molecule. Oxygen is a diatomic molecule. So one atom contains half molecule. One atom contains half molecules, we can say. One atom contains half molecule. So next we'll see here. We have written the word mole. We have written. Since we have written mole, we have to write here also. We have to include mole. We have to include mole. Mole we have to include. Here also we have to write mole. We have to include. Here we have to write mole. Here also we have to write mole. That means I will write clearly. 1 mole of water. 1 mole of water contains. 1 mole of water contains 2 moles of hydrogen atoms. 2 moles of hydrogen atoms. That means it is 1 mole of hydrogen molecules. 1 mole of hydrogen molecules, because hydrogen is diatomic. And 1 mole of oxygen atoms. 1 mole of oxygen atoms. 1 mole of oxygen atoms. This we can write. This we can write it as a half mole of oxygen molecules, because oxygen is diatomic. Okay. So 1 mole of water. 1 mole of water contains half-mole of oxygen. Half-mole of oxygen. So 1 mole of water contains half-mole of oxygen, isn't it? Therefore, in the question what is given, what they are asking, 2 moles of water is given. How many moles of oxygen molecules? How many moles of oxygen molecules is the question. Okay. So 2 moles of water is given. 2 moles of water is given. Sorry, water how much given means 2 moles of water. So 2 moles of water contains how many moles of oxygen molecules? That is equal to this 1 by 2 into 2, which is equal to 1 mole of 1 mole of oxygen molecules. 1 mole of oxygen molecules, we can say. Therefore 1 mole of water contains half mole of O2, means 2 moles of water contains 1 mole of oxygen molecules. 1 mole of oxygen molecules, like this we can say. 1 mole of oxygen molecules. So okay. Next we will see another type of question we will take. Another type of question we will take. Now we are considering, we will consider polyatomic molecules. Polyatomic molecules. What is its atomicity? What is the atomicity of polyatomic molecules? What is its atomicity? What is its atomicity? So what is the meaning of atomicity? Atomicity means number of atoms per molecule. So poly in the sense what? It is more than 2. Therefore atomicity is how much? Greater than 2, we can say. So polyatomic molecules, for which what is atomicity, we can say greater than 2. Greater than 2, we can say. Okay, we will continue in next class.